Just now what I discussed theory, that only it is just available as numerical. Just now what we discussed theory, no, that only is available as numerical. Okay, no, let me begin. I'll get you the diagram. This is the first question. Okay, focus on the basic ideas. Then it will be easy for you. Huh? Okay, this is the thing. So 2 moles of monoatomic gas. So 2 moles, you write it. Include adiabatic cylinder. All are non-conducting. The piston is connected to vertical spring or spring constant. So it is having a spring constant. The area of cross-section of cylinder, that the initial spring, is at its natural length. Okay, the relaxed. You write it nearby. Relaxed. Okay. Then he has given atmospheric pressure. So what are the forces that will be acting? P naught A. The area of cross-section of cylinder is natural length. The gas is heated slowly by means and piston moves up by 10 centimeter. Okay, this is the X. What about the mass? What about the piston? Fitted with a smooth, light adiabatic piston. Will there be any mass? Weight of the piston will act? No, it's a light, is telling massless. Okay, now the pressure, let it be. So initial pressure, how much it will be? P naught only. Okay, now the P naught A will act and the pressure PA and the spring is compressed. Okay, spring force. This is the thing. Okay, now the gas is heated slowly for some time by means of an electric heater. That electric heater, I'll show it here. There's a heater coil. Get in this one. So initially, we don't know any, and its natural temperature of gas is T1. So initial temperature T1. Initial volume, let it be V1. Final volume V2. Or V, you write it. And the temperature, let it be T. Okay, let's get into work done by the gas in the process, quantity of heat supplied by the heater. So initial temperature, let me take T naught, V naught. Symbols will be easy for us. So, okay, let's do one thing. Looking at this massless, it is once again. Let's get into this one. What is the pressure of gas? Looking at this equation, P naught A, PA minus P naught A minus Kx equal to 0. P equal to P naught plus Kx by A. Fine. This is the looking at the final one. And then what is the volume? The volume of gas should be V naught plus AX, no? Because the piston got shifted up. So then initial volume of gas, can we calculate? Initial volume of gas using ideal gas equation, P naught V naught equal to nR T naught. Initial volume equal to nR T naught by P naught. What is the pressure of gas? Will be P naught. Sir, how do I come to know? I think that is what you have to make observation. What is the state of piston? Massless piston. At rest, no, initially it is. So net force on it should be 0. So what is the only force acting? The force by the air and by the gas. This is a condition. Okay, we know initial volume. We know number of moles are T naught, P naught. Substituting We'll get the condition. Okay, V naught we know. Okay, then A. So can we don't know what like work done by the gas, no? Now for that, what shall I do? We know X. Okay, let me use ideal gas equation once again. PV equal to nRT. Let's see what I'll get it. So this is P naught plus Kx by A volume V naught plus Ax equal to nRT. Do we know P naught S? Do we know A S? Do we know K? No. Do we know X? X. What is X equal to? 0.1 meter. Agree this one. So from that we'll get the temperature. So expression for T will be just very simple idea based. Just a student has to make observation. That's all. Okay, we'll get the temperature of the gas. After getting temperature of gas, then let's come for the work done by the gas. So what is work done by the gas? Any process PdV. Okay, this further pressure what you can write. Okay, change in volume. Sorry, this is AdX. So 0 to x. So this should become equal to P naught Ax plus Kx square by 2. Okay, I got the work done by the gas. We know P naught A X K all will get the work done by the gas. Okay, no. How to get the heat supplied? Shall we take help of first law of thermodynamics? So what all heat I supplied, what will happen to it? I supplied an heat. So what is Q? Q is a heat supplied. Who will supply the heater coil? I need not to show, just for students to understand. No, I had to write that Q. The heater coil will supply the heat. So shall I say first law of thermodynamics? What all heat supplied by heater coil equal to delta U plus work done by the gas. What is delta U? 2 moles of monoatomic gas, 3R by 2 into final temperature T minus T naught. Do we know temperature? SS from here. Okay, that I'm going to substitute. I'll get this one. Plus work done by gas. Work done by the gas is what? You calculated from here. This slightly it will come. So some it will come around 21 and 804, not 20. I'll make an correction. So this will be the correct answers. Can you work out? I'm just giving the idea. So what are the basic things? You have to go back to mechanics. What are the forces that are acting on piston? Get expression for pressure force, work done by the gas from there. Then first law of thermodynamics and ideal gas equation. You can see here, initial volume we don't know. How to calculate volume of gas? Okay, there's a method. Just you have to fight with the terms which are available here. I'll scroll down. Read this one.